Alright, so let's continue with evaluating argument. And I'm going to focus on evaluating deductive arguments because, like I said, they're more relevant to talking about moral theories and moral arguments. They're also easier to evaluate for reasons that will probably become a little clearer with this lecture. So we're leaving inductive arguments behind, as interesting and as important as they are, and as much as I would actually like to talk about them, you can't do everything. All right. So how do we evaluate an argument? Well, there's two steps, and these two steps actually hold for inductive arguments as well, but we'll focus on deductive. So first you look at the form of the argument. And the form of the argument is the way the pieces fit together, right? The way that the premises are supposed to support the conclusion. Think of this as like a plan for a building or a plan for anything. How are the pieces supposed to fit together? Then you look at the content or the premises. Are they true? And you might look at this second step as thinking about the material something's built out of, right? Look, you can kind of think of an argument as a structure, as something that's supposed to support this conclusion, right? And if you want to build something that's going to stand up, especially something that's going to support some weight, you want the pieces to fit together in the right way. If they don't, no matter what you make it out of, it's going to fall down, it's not going to bear any weight, right? But you also want it to be made out of good material, right? You can take cardboard or balsa wood, balsa wood, the stuff they make those little gliders out of, really light, really flimsy. You can put it together as well as you want. It's not going to support a lot of weight, right? You can take steel or brick, and if you don't put it together the right way, it's not going to support much weight. You can put flimsy material together as well as you want. It's not going to support a lot of weight. For something to bear a lot of weight, it needs a good form, a good plan. The pieces need to fit together in the right way, and it needs to be made out of good material, right? Same with arguments. They need a good plan, they need a good form. They also need good premises, preferably premises that are true, or at least premises that are plausible. We'll talk a bit more about that later. So, for a deductive argument, in any argument really, the first thing you probably want to do is to think about the form of the argument. And this kind of saves us some work, right? Because if the form's bad, you don't need to think about the material. You don't need to go through and say, well, are these premises true or not? You know that it doesn't matter, because even if they're true, even if they're strong material, this thing's just not going to hang together. It's not going to bear any weight. You also want to think about this when making your own arguments. The first thing you want is for the pieces to fit together in the right way, because if they don't, no matter how careful you are in coming up with your premises, the argument's not going to work, right? All right. So for deductive arguments, evaluating the form comes down to answering this question: is the argument valid or not? We talked about validity last lecture. The first step in evaluating a deductive argument: is it valid? If it's not valid, you don't need to go further because it's not a good argument. So how do we figure out if a deductive argument is in fact valid? There's a few methods. So one method for showing that a deductive argument is invalid is the method of counterexample. Think of a way the argument could be false, a scenario or a situation where the argument is in fact false. If you can think of a way where the premises are true, any situation you can think of where the premises are true and the conclusion is false, that shows it's not a valid argument, because remember, if the argument is valid, it is impossible for the premises to be true and the conclusion false. So here's an invalid deductive argument, and we'll use this method of counterexample to see why it's invalid. All dogs are mammals. Moxie is a mammal, so Moxie is a dog. All right. How could the premises be true and the conclusion false? Moxie could be a gerbil. Moxie could be a cat. Moxie could be a child, right? Again, slightly odd name for a child to call them Moxie. At least I think so. You know, like it as a dog name, but one of these days I'm going to get in trouble because somebody's going to have a kid named Moxie and they're going to really blast me on student evaluations, but whatever. I think it'd be a slightly odd name for a child, but you could name your baby Moxie, right? If Moxie is a cat or a gerbil or whatever, it is true that she's a mammal. It is true that all dogs are mammals, but it is not true that Moxie is a dog, right? That is one way it could be false. Let me give you guys another example. Every time we have snow and it sticks to the roads, TCC cancels classes the next day. Or that day. That is true, right? If we have snow around here and it sticks to the roads, even if it doesn't stick to the roads a lot of times, we're going to cancel classes. But if it sticks to the roads, we will definitely cancel classes, right? TCC canceled classes today, so it must have snowed. Well, can you think of a way that those premises could be true and that conclusion false? Well, there's a lot of reasons we might cancel classes, right? If we have a hurricane bearing down on us, we're going to cancel classes, right? Snow is not the only form of winter weather that will cancel classes, right? If we have an inch of freezing rain, that would also cancel classes, right? I had a student a few semesters ago, we were talking about this, and his counterexample was like, well, if there's a nuclear war, and I'm like, yeah, we would probably, if we were around, we would probably cancel classes for that. That's a pretty bleak place to go, It's like, geez, I thought I was bleak with like a hurricane. But anyway, the point being, you can imagine all kinds of cases where it's true that we cancel classes, and the statement, if it does snow, every time it snows and sticks, we cancel classes. That's true. You can imagine a lot of cases where both are true, but it's false that it snowed, right? Because there are lots of other reasons we would cancel classes. Right? Here are my examples. Sleet or freezing rain, hurricane, other catastrophes or emergencies. Now, the counterexample method is important, but it's often a lot of work, right? It's often really hard to think of a counterexample, and even if you can't think of a counterexample, even if you can't come up with a counterexample to the argument, that doesn't show that it's valid, right? Just because you can't show the argument is invalid doesn't necessarily mean that it is valid, right? The argument might be invalid, and we're just not clever enough to think up a counterexample, right? This is why thinking about valid forms of argument is so important, and learning to recognize valid forms of argument. We're only going to talk about a few in this class. Again, if you want to talk about more, take a logic class, which we do offer. Most colleges do, some high schools do, right? So, valid forms of argument. Certain forms of argument are valid, and if you learn to recognize the argument as having this valid form, you don't have to bother with coming up with a counterexample or any of that. You know the argument is valid. On the other hand, there are what philosophers and logicians call fallacies. And fallacies are forms of argument that look valid, that a lot of people will take to be valid, but they are in fact not valid. These are forms of bad argument that trip people up, that fool people. If you spot a fallacy, you know the argument is invalid. So, if you recognize a valid form of argument, you know it's valid. If it uses only valid forms of argument all the way through, we know our argument's valid. If you spot a fallacy anywhere, though, you know the argument is invalid. We're going to look at two valid forms of argument and two fallacies. And both involve what philosophers call conditionals. Conditionals are if-then statements. We look at those because these are actually going to be really important for the class. We're going to use these conditional arguments a lot. We also look at them because people mess up conditionals all the time. To my mind, some of the most common fallacies people make involve conditional statements. So here's the first valid form of argument, modus ponens. If A, then B, A, so B. All right, that's really sketchy. Let's put some detail on that. If it snows and sticks to the roads, TCC will cancel classes the next day. That is true, right? It is snowing and sticking to the roads, so TCC will cancel classes tomorrow. If it snows and sticks to the roads, if A, we will cancel classes the next day. B, 2 says A, it's snowing and sticking to the roads. 3 says B, we're going to cancel classes. Here's another example. If Bob goes to every ethics class, he will pass ethics. Bob has come to every ethics class, so Bob will pass ethics, right? If A, he goes to every ethics class, then B, he will pass. You know, a lot of times people will leave the then out as I have here. You know, it's implied. A, he's come to every ethics class, so B, he's going to pass, right? 3, slightly darker one. You know, if someone wages a war of aggression, they have committed a war crime. Vladimir Putin is waging a war of aggression. Vladimir Putin has committed a war crime. If someone wages a war of aggression, A, they have committed a war crime. B, Putin's done this. A, so B, he's committed a war crime. All right, so modus ponens, and don't ask me what that means. I took Latin in high school, but my Latin teacher was having a midlife crisis, so I did not actually learn much about actual Latin. Learned a lot about why he thought his marriage failed. Learned a lot about why he didn't like his job teaching high school Latin. I did not learn much at all about actual Latin. Anyway, modus ponens, you know, just the jargon. You don't even really need to remember the jargon. Just remember it's a valid form of argument. That's what's important. If A, so here's our second one though, modus tollens. Kind of the mirror image of modus ponens. If A, then B, not B, so not A. So this is telling us anytime you have A, you're going to get B. And you know if that's true if you don't have B. If whenever you have A, you get B, well, you know if you don't have B, that's a sure sign you don't have A, right? That's why this works. Here's a few examples. If it snows and sticks, TCC will cancel classes the next day. TCC did not cancel classes today, so it did not snow and stick last night, right? Look, you know, imagine, you know, you're wondering if we're going to get snow. You know, in this region, a lot of times we don't know. It's like, well, we're either going to get 5 feet of snow or it's going to fall as a slightly cold rain. We won't know until up an hour before it happens, right? I exaggerate a little bit, but not much. You know, if you wondered if we got snow, so imagine you have a room without without windows. If you logged onto the TCC webpage and you saw we were having classes, you would know very well we didn't get that snow, right? Because if we did get the snow, we would cancel classes. You know, since we didn't get cancel classes, we didn't have the snow. Bob comes to every class, he'll pass ethics. Well, if that is really true, we know from the fact that he didn't pass, that he failed, that he didn't go to every class, right? Here's one more. Slightly more controversial. Hopefully not that controversial, right? If the COVID vaccines really had microchips in them, the needles they used to give them would be huge, right? I mean, look, a microchip's pretty big, even a small one. You'd have to have pretty big needles so the microchip wouldn't get caught, right? One of those like, I don't know, one of those huge ones you see in like horror movies or whatever, or on those TV shows with veterinarians giving shots to cows, right? Anyway, the needles they use to give COVID shots are not huge. You've probably had a COVID shot. I've had like 3 of them. The needles are not that big, right? I mean, look, they can stand to be smaller, I think. I mean, I don't really like needles. Who does? But they're not huge, right? They're normal-sized needles. If they had microchips in them, the needles would have to be huge to let the microchips through. Well, from that fact, you know that since the needles aren't that big, the COVID vaccines don't have microchips in them, right? Ergo, that's another word people use to like indicate conclusions. It's a slightly pretentious one, but whatever. We'll mix things up a little bit. Keep it from getting boring, right? All right. So modus ponens, if A then B, A so B, and modus tollens, if A then B, not B so not A, are 2 valid forms of argument using the conditional. There are other valid forms of argument that use a conditional. We're not going to talk about them because they're not going to be super important for this class. Take a logic class. They'll go through more. I want to talk about 2 fallacies involving the conditional. Affirming the consequent and denying the antecedent. Well, here's affirming the consequent. If Laura does all her homework and comes to every class, she will pass calculus. Laura passed calculus, so she must have done her homework and went to every class. Well, how might this be false, right? Maybe she missed every class and never cracked a book, and is just freakishly good at math, right? She just gets an A on every, perfect score on every single test. Maybe she didn't go to class. She just didn't like going to class, but she hired a tutor, and that guy taught her all the material she would have gotten from going to class and doing her homework, right? Maybe she cheated, right? Can't rule that out. People do that. Or maybe she has one of those lazy, timid teachers who won't fail anybody no matter what. I had a teacher like that when I took trig. Big surprise, I didn't learn a lot of trigonometry, right? But, really, to understand what's going on here, think about what the argument actually says. Think about what it literally says. It says that doing all of her homework and going to every class is one way for her to pass the class. One way to pass the class, at least one way to pass the class, is to do these 2 things. The argument never says it is the only way to pass class, right? If it were the only way to pass class, this would be a valid argument, but the argument never says that. Since there are other ways, or at least it's possible that there are other ways she could pass class for everything that the argument actually tells us, it's not a valid argument. Fallacy 2 is denying the antecedent. If Laura studies hard and does all her homework, she will pass calculus. She hasn't studied hard and done all her homework, so she's not going to pass. Look, this argument is invalid. It's a fallacy for exactly the same reason that affirming the consequent is, right? For the argument to be valid, we'd have to say, well, the only way she can pass is to do these 2 things. If she doesn't do these 2 things, then she's going to fail. But because the argument never says that, because there might be other ways to pass the class for all the argument tells us, it is possible for these premises to be true. If she does these things, she'll pass. She hasn't done them. It is possible for them to be true and the conclusion false. Same with the other one, because there might be other ways of passing class, 1 and 2 can be true and 3 false. Remember, valid means there's no possible way premises can be true and conclusion false. There are possible ways these premises can be true and the conclusion false in both of these fallacious arguments. They're invalid, they are fallacies. Never be fooled when you see arguments that affirm the consequent or deny the antecedent. A lot of people are tripped up by these. That's why I take the time to talk about them, even though our section on logic is relatively short. Know that they're bad arguments, know that they're invalid, don't fall for them.